Okay, guys. So just to start with, um, I will share my screen. So we have a small document which I will send it today after this. So just to start with, do you guys have any idea of Terraform?
No, sir.
No, sir.
Okay. Okay. So yeah, see, I think if you don't know Terraform, I think we need to take a step back and think about what is exactly is the current problem that this particular tool is fixing. So in a DevOps, in a shift, if you take any of infrastructure of any of the company that we work, so every company will have some kind of any company you have a lot of applications, and every application that we actually deal will have some kind of infrastructure. Okay, so can you guys tell me any of the application that you use in day-to-day activities? Just to first to start, any application that you normally use, or any website or any software that you normally use day to day?
Like
Can you
SQL
mention?
Server.
The SQL Server is one of the component, but I'm just saying, tell me an end user application that you use, like banking app or something like that. Just something to get the context.
Amazon.
Okay, is it Amazon website or e-com website you're talking about?
Yes, e-com website.
Okay. Okay, let's see. I mean, there are hundreds of applications in the world. Just take e-com. Okay, let's just be very easy to get that kind of. Okay. Okay. So I'm just say because you said that, let us say every application in the world will have some architecture. So as a DevOps, the first thing that you will need to start to do anything is you need to have a architecture. Okay, example, you are a builder and you want to build a house. What is the first question that you will ask me?
Plan.
Plans.
Okay. Anything else? If you are building a house and you be called a builder, what will he ask?
Architecture.
So that's called architecture. So that is exactly I am Googling here. So for a typical e-com, what is an architecture? And let us take one architecture and start our understanding through this. Okay. So don't go to this AWS architecture, then you will be like thinking about AWS only. But this session, I want to be cloud agnostic. So I don't want you to think like you are talking about AWS. The one of the main reason advantages of Terraform, which we will discuss in detail, is it is technology agnostics. So you don't need to think about it. Supports multiple clouds. Okay, so that's the reason why if I'm looking, so there are some diagrams which is specific to AWS. I'm trying to avoid that. Okay, so this is GCP. I'm trying to avoid that so that we will have a proper um, diagram. Let us just take a little complex diagram because I can see some simple diagram, but I want complex one because that's where you guys will come into picture as a DevOps. Okay, let's see what is this guy talking about. This is again AWS. Let's talk about again. They're talking about Google. Let's take something else. Google Cloud. Um, Learning management system. This is not this one. This is typical web server load balancer adaptation. Yeah, looks okay. Okay. Let's take this DB at a typical architecture. I think it should be. I think this is better. Yeah, okay, let's take this, guys. Okay, this is one architecture. That let's take this architecture. Don't worry about other things. So let's take it here. Okay. Now, if we go depth somewhere here, we have this architecture. Okay. Okay. If you see this architecture, what are the components that you can identify? What are the different components here? I think you've spoken about SQL Server, right?
Yes, sir.
So,
Data tier.
okay, so let's identify a few things. Yeah, in this you have data type. What else you can see here, guys?
DMC, web tier, and business tier.
Okay, so okay, DMZ. Okay, this is fine. But in this, what are the components that you can see? Boxes.
Load balancer.
Exactly, you can see one load balancer here, and this is more of a front end. It's like a web application, and the traffic will come to the load balancer, and you have so many. Can you see these 3 VMs here?
Virtual machines.
Okay, so yeah, this is where you people will be very handy. So there is one virtual machine, right? So how many virtual machines are there?
Multiple 3 here. Yeah.
3.
6
Okay.
totally.
Yeah, total 6 plus there 2, 8 plus 1, 9.
Oh.
So what? Okay, so now let's go. So you can see a load balancer, you can see virtual machines, you can see an SQL server, and you can see a web load balancer, which is at the front end, which takes our CDN and those kind of things. And we got some jump box. Okay, just ignore about jump box for now. So we have a virtual machines, load balancer, and SQL servers. Okay, so these are 3 components that you can see in this architecture. So example, in your company, your architect had given this diagram. And then where Terraform will come into picture? Okay, any idea if you get this
Load balancer, maybe.
To run the VMs through scripts, codes.
is this important topic in DevOps called Terraform. And this is a workshop for us to explain what is Terraform and how it works. So this is just a workshop. We're not talking about any demo or nothing. This is just to talk about Terraform and one topic that you people can learn today. Okay, so we're talking about Terraform. Hope from here you will continue, so you will understand. Cool. Shini, I think she left. Okay, it's fine. Okay, guys, the remaining people are from past. So here we had taken one architecture of an application, an e-com application like Amazon, and we had seen that there's an architecture. So when you guys go to a company, they will give you that okay, this is an architecture. Now, as a DevOps, you go and start building the infrastructure. So the first part that you will do in your company is you need to build the infrastructure, because you get architecture, because you are not architect. Okay, maybe there's somebody who will do architect. So architect will do it. So what you will do first? Build the infrastructure. So to build the infrastructure, what are the components that we have? We have virtual machine, and we have SQL server, and we have load balancer. Okay, now this is the first thing you need to do. Now to build this, you need to have a cloud, or you need to have a server for this, right? Okay, traditionally, even one server, even in a Windows machine, they can spin up all these things. But now it's very next level. We can spin up in a bigger server, or we can spin up in a, what is the meaning of spin up is starting the server. So like, running the server. To run this server, we can run in cloud or in server, on a physical server. Which one you guys think is preferable? Running in a cloud or running in a physical server?
Depends
Cloud?
on kind of business. If it is a big business, they can have their own personal servers. If it's a small business, they can opt for cloud services.
Okay, very good. What is who's next?
I said cloud, that would be more feasible these days. It's available 24/7.
Mm-hmm.
And it can be run on any account, like anyone can use it, user friendly.
Mm-hmm. What is the
So
other
we don't
advantage of cloud?
depend on a computer. Everything should be on cloud, so we can access from anywhere.
Cost efficient.
Very important. Yes, cost. Okay, and easy to maintain. And also it is accessible to everywhere. And it is also advantage of cloud is scalable. Yes, exactly. Okay, and the cost point of view is very costly because it can be on demand. Okay, example, you don't need to use a server because that's particular. Example, you don't have a database, you are not ready with anything, so you don't need to pay for the maintenance of the server itself, because if you have buy a big server, then you need to maintain that, right? So maintenance is not required because you don't need it at this point. So that's called on-demand services. Okay, that's where AWS was a big hit because it's an on-demand service. So you can only use on demand. Okay, so yes, let us think that we need to spin up all these things in cloud. So what are the different options available as a cloud, guys? What are the different cloud options available for us?
AWS, Azure, GCP. IBM Cloud is also there.
IBM Cloud, GCP. What else?
AWS, Azure.
Now, which one is good out of these four?
I think so. AWS is initiated cloud services first. Then I think so. Azure is giving a complete package with the Microsoft service, other Microsoft services. They both are leading cloud services, I guess.
Okay, anyone else? Which is the best cloud?
Yeah, I'm same as Dilip. Like AWS and Azure are the leading one. It has all the features, current features. When compared to AWS and Azure, IBM and GCP are less features. Still, they are evolving.
Okay. Okay. Anybody else? Yeah. So I will tell everything, as you guys said, everything is having advantages and disadvantages. But my point of view, the answer is it's a company's decision. Okay, so your company will decide which to take. But here is the problem. This is where exactly Terraform will come into picture. The company will say, today use Azure. And after 6 months, they'll say, I think Azure is too costly. Can we go with AWS? Okay, then as a DevOps, what do? Will you say, yes, I can? Or will you say that, no, it is already, we spin up everything there. It's very hard to take it out. What do you guys think is the answer? Whether you say that, yes, I can migrate, or you will say that it's very hard to migrate.
I mean, it should be migratable for the company. He can like time because time the prices will be changing, so company can decide which service to use. So that flexibility should be there.
Okay. So you said migrating can be possible. That is one way. But what would be the cost of migration?
Depends. If if there any automated system, then it will be cheap. But if it has to be done manually, it will be costly. I think so.
Okay. Okay. Now the answer for that is, if you build your infrastructure, this is where exactly we all were coming into one place. To build this infrastructure, okay. So example, we'll say that company will decide. Company said that okay, but as a DevOps, to build this infrastructure, and to maintain it, then you can actually say that, can we build the infra using Terraform? Okay, this is exactly the Terraform is coming into picture, but these kind of things can happen. So what Terraform can do? Terraform is a tool which can easily run your infrastructure without having any technology dependency. So Terraform is an open source cloud agnostic provisioning tool developed by HashiCorp. This is a company, and written in Golang. So it is an open source cloud agnostic provision tool. What is the meaning of cloud agnostic provisioning tool? What is the agnostic word, guys? What is the meaning of cloud agnostic?
It says, I mean, the meaning says a person who is uncertain or non-committal towards something. I mean, it can be anything, like it's
Independent of the two.
Okay, one is independent, one is yes. Okay, any other answers? Anyone? Yes, I want everybody to talk a little bit. Okay, just asking the meaning of agnostic. I'm not asking anything. Can you guys please, everyone please reply? It will be nice to have an interactive session. So my question is, what is the meaning of agnostic? Pooja, you're around.
Yeah, hi. So it means that can be moved across multiple clouds, as in if it is built in Azure now and can be easily moved to AWS.
Yeah, movable. Okay. Right. Okay. Very good answers, guys. Anyone else want to add? Because I can't see you. I was like, just wait for you. Okay. Yes, exactly. As you all said, what is Terraform? Terraform is a technology as agnostic tool, which is independent, and it is, oh sorry, very bad spelling, independent. Okay, and it can be changeable. Okay, as Pooja said. Okay, so what does that mean? So now technically you can build the whole infrastructure, which is this, by having multiple tiers, and you have multiple VMs, multiple load balancers, everything you can, instead of manually going to AWS and starting. Okay, example, if you want to go to AWS, please see my screen, guys. I'm actually going into AWS now. So, okay, where is AWS? I try to go to AWS. Give me a second. Sign into console. If you don't have sign in the root. Okay, so if you don't have AWS account, you can do it later, guys. But it is nice to have it. I have some code which I will. Okay, 1 second, guys. I think I need to 1 second. 1 second. This is why I'm trying to log into my AWS. So admin account. They had sent an email. Just 1 second, guys, because they added this two-factor authentication nowadays. Where are we? My email. 1 second, guys. I'm just trying to log into AWS. Logging into this because they started this new way of logging into AWS. See here, now I got a phone number verification and it is completed. Now I am into my AWS account. Okay. Now, if you just go back to our original question that we discussed about this load balancing. So we have load balancer, we have this SQL server. Okay, that is the three component that we identified. Now go to AWS. If I am a old or traditional DevOps, what I will do? Okay, I will go to EC2. I'm in EC2. Just start a launch instance, and then I can start an instance here. That's how we will start a EC2 instance. So if I'm a traditional guy, then I will try to use this. Similarly, I will start an SQL server, go here, click on create, and then do blah, blah, blah. Then I will get the SQL. Similarly, load balancer, I go to load balancer and go to create a load balancer and complete it. So that's how the load balancing works. So that is exactly why what I can do it in 10 minutes, I can build the whole infrastructure for you people. But that is an old way of doing the things. What is the latest way? The latest way is you can use a Terraform to do that. What Terraform will do here, okay, is you don't need to manually start anything. You can build the infrastructure using code. Okay, so it gives you an option to write a code to build the infrastructure. Okay, so what is that possible? Because you write one-time code, and that code you can write it, and you can show that code to. In the code, you are saying that I need load balancer, and you are talking about I need SQL server, I need a web server, and a virtual machine. Only three things. But where you run the code, if you can plug that into AWS, then in AWS whole infrastructure will start and run. But if you think after 6 months, let us go to Azure, then you don't need to again start everything from scratch. The same code, click on apply button, then your whole infrastructure in Azure will start. So you are actually automating the infrastructure building using a code. That is called Terraform. So it is used to automate the provisioning of cloud resource. So it automates. Okay, so what is Terraform now? It's an automation tool to build the infrastructure. So whatever I'm doing manually, clicking these buttons, 100 buttons in AWS, right now you can see here, I can click on create, but this is all nonsense. Why I need to do that? I can do that using a code. That is exactly what I will show you today. Okay, so what is Terraform? Please guys, listen to me, it's very important. So this is a tool which is built by HashiCorp company. And what they do is you can use your code to build the infrastructure, stop the infrastructure, maintain the infrastructure, change the privileges, anything you can write the code. It's like, you're writing a Java code to build a application. You are using Terraform code to build the infrastructure. Okay, which is very helpful. Okay, that is Terraform. Terraform is a tool which is used to automate the provisioning of cloud resource. That means that you can build an infrastructure using some code. And that code is written in a language called Go language. Okay, so now if we go back to Azure, Terraform. So what is Terraform? Terraform is actually created by this called HashiCorp, and it uses Go language, okay, to build the infrastructure. Okay, so it uses Go language to build the infrastructure. And what else Terraform will do? It will help to run the code anywhere. It can be local. You run the code in a different you can run the code in Git. Okay, whatever it is, you can run anywhere. So you can run that code to build the infrastructure. So it helps to write the code. Okay, and it helps to write the code. It helps to run the code. It helps to build a whole infrastructure automatically. Okay, that is an advantage. That is what Terraform. So Terraform is a tool to build your infrastructure using a code. So infrastructure as a code is the answer. So it's an infrastructure as a code. It uses some coding to build the infrastructure, which is like ecom. Just now we're talking about ecom. Okay, so you guys understood a bit of Terraform now?
Yes.
Yes, sir.
Okay, Pooja, you understood?
Yes, I did. Thank you.
Okay, Bhavya?
Yes, I'm trying to understand because I have joined late.
Okay, okay. You will get a recording, but yes, if you have any question, you can ask. Okay, KK, hope you understood.
Yeah.
Okay, now let me ask you guys one question. What is the language which is used in Terraform?
Go language.
Very good. Okay, Go language. What is the company who's supporting Terraform?
HashiCorp.
HashiCorp.
Very good, nice. Okay, is Terraform cloud agnostic or it is cloud diagnostic? Like, is it independent or is it we can use only for one cloud?
Cloud agnostic.
Independent.
Independent. So what are the cloud platforms? What are the cloud platforms the Terraform supports?
All
You mean?
like AWS, Azure, GCP, and local server also like.
Yes, I think it won't support local server. I'm just giving an example, but Terraform won't support local server. It only supports GCP, Azure, and AWS.
Okay.
Yeah.
Yeah.
It won't support IBM.
Okay.
Okay, so yeah, that is a kind of, that's a nice thing to know. Okay, what else? Terraform point of view. So far, what we learned. What is an alternative way of building an infrastructure without using Terraform?
Going to the cloud service and creating the services with the help of user interface of the like a different user interface of the cloud service.
Very good. Very good. Exactly. Okay. So you can directly, if there's no Terraform, example, you joined and you don't know Terraform, then doesn't mean that you cannot be a DevOps. Okay. You can still manually go and do it. That's what small companies will do. Okay. Because there'll be one admin who will do this, but proper companies will not do that. Okay. You can still do it. So, I mean, it is just an alternative tool. Cool. Okay. Do you guys have any question before I go to the and start doing some coding and showing some magic? Any questions? Anyone?
Sir Dilip here. Sir, if there is an already existing architecture in GCP or Azure, can we alter it, make any changes in the architecture using Terraform?
Yeah, that's a good question. If there is an existing in, so yeah, there is one feature in Terraform where you can actually see, especially if it is in any of these things only. There is one feature in Terraform where you plug it to the existing infrastructure. It will read the infrastructure and write the code back.
Okay.
So, example, 10 years back you developed where there's no Terraform. You just plug your infrastructure and it is like reading the whole infrastructure. So it have an option to, it have an ability to read the infrastructure, and then it will create the infrastructure code by its own. It's like a reverse. Okay, and then you can update it. Yes, and then you can update anything. And example, you want to add a server, then you write the code, add the server, and run it again. Then what it does, it keeps existing infrastructure and it adds the new thing. It updates. But for that, it's a two-step. Okay. Normally, if you have already an infrastructure code, then you just update your script and run it. It will go and update the infrastructure. If it is they may done manually, then you can read the existing infrastructure using Terraform, and then you go to update the file and run it.
Okay. Makes clear. Yeah.
Okay. Okay, let's go to the next topic, guys. I think we have 1 hour session, so I'll give this document to everyone, guys, after this. So now, when you actually want to use infrastructure Terraform in real time, how the Terraform look like? Okay, it's very simple, guys. In the real time, you just need to go to terminal. See, basically, there are two ways. Okay, one, on your local system also you can run an infrastructure and you can run the Terraform, or if you are in a bigger company, to run the actual Terraform also, there will be one server. Okay, so you won't be able to run it here. That particular thing will run it through server. It can be GitLab, or it can be GitHub, or it can be the lot of tools where it itself gives an option to run something from a server, because running from local machine is not an ideal thing. So there will be a job in your CI/CD pipeline. I mean, I don't want to talk too many things in DevOps, but in a CI/CD pipeline, you will have a job. In that job, will run on a server. That is the place where you can see Terraform. Okay, so but locally also you can test it and run it. Okay, to install this, I mean, I don't want to go to the installation right now, but maybe if you guys want to come, need one more session, then I would suggest you can go to Terraform and you can install it. Okay, so right now I don't want to show installation, it will take some time. So this is the company. You can go here, you can actually download the so you can see here they got product, and you can actually go here and there will be an option for you to download it. Okay, so it's not the, yeah, it's a download, and then there will be some kind of a documentation for installing the install Terraform. It's as simple as this, guys. Example here, see here. If it's Mac, you can see here. I'm in Mac. I just copy and okay, maybe two commands at one go. I mean, I don't want to run on my machine because this is a personal laptop, but I'm just okay, even Brew is not installed. I'm not ready for this, guys. I need to install Brew, and then only one line I need to do. Brew tap #, install #, Terraform. This is the two commands. If it is Windows, then you can download it physically. And if it is Linux, this is the command to install your Terraform. It's very simple. Okay, like for me, it takes like 10 minutes to do it. Doesn't matter. So maybe next class, if you want to one more session, then maybe we at the end of the class will discuss then I will give you some links for you to install it. And next time when you install and come, it will happen. It'll be easy. Okay. So now what I am telling all these things is if you have if you install it, then there is some commands that you can actually practice. So what are the main commands that we are looking here? So there's one command called Terraform init. Terraform init is a command, means actually it's it actually initiates a project. Example, you want to start a project, so it is the one command that you can use is Terraform init. So just you need to run this command. Example, you might get in here after installation. There will be I don't know, I mean, like after this particular command is finished, then you will be able to run a command called Terraform. So if you example see my laptop, now nothing is happening because it's not installed. But next time I will be showing, if you run this command Terraform init, then it will create a folder for the whole project of Terraform. It creates some file, so it creates a project. That's what Terraform init. So Terraform init is a very important step to start a project. So it creates a folder structure for you. Similarly, Terraform plan is one of the next command. So what is the plan? So plan is actually, it will not do any deployment. It will check whether the code that you had written is valid. Means do you have a list, because in the folder structure you will have some files. So do you have the right files, and if the syntax is correct, if everything is ready for you to build the infrastructure, it does some validations. The plan is that you are planning and you're checking that whether your existing code is perfect or not. Okay, for an example, listen to this, guys. I'm just showing some example of a even this I will give you in your this one. So example, this is one of the this is one of the folder structure that this is how it look like. If you can see this code on my screen, I don't want to make it very complicated, guys. So I'm just trying to show you how the code will look. Example, if you are looking for a Azure, this one, so there is some samples. So this is how the actual Terraform code will look like. Okay, so it will look like this. So you can see here, this is your Go language, HashiCorp Go language, and this is how you write the code. Okay, so you can see here, for an example, you are creating Azure storage account. So you're creating one storage. So this is the name of the storage. This is the resource group. This is the location, and this is the account type standard. And you are telling that there's some parameters. So this line of code will give you an access to create one specific server. And what kind of server is that? It's a Azure storage account. Okay, similarly, let us see something else. Okay, because you got access to this example, you want to create a Linux virtual machine. This is how it looked like. Okay, you can see here, this is Terraform, blah, blah, blah. This is the basic. And then you go to provider Azure, and you can go and simply say, this is the location of your server. And this is your name of the resource. 1 second, guys. One. Okay, guys, sorry. Yeah, so now you can see here, we created a simple Linux virtual machine. Okay, and here it's all configured here. Okay, and we can even go to the IP configuration. We can do some subnet and IP level. Like you can go to the IP level. I don't want to go in that detail, guys. So this example, this virtual server, virtual machine will have a dynamic IP. So that example, you are running in the banking application and all, you will always go with dynamic IP, so that your IP address of your system changes within your network will change so that nobody can hack. So these kind of, even you can do everything, whatever you have to do it manually. Example, you are creating a load balancer. There are a lot of parameters. This all per example, see here, load balancer IP address. So everything that you can see here virtually can be written through code. Okay, so that is how this is talking about. So now coming back to your original thing. So when you have this code ready, but you need to check whether the code is ready, because you run it, and in the middle example, you are creating 10 servers. Example, going back to the original infrastructure, you have to build the whole infrastructure. Suddenly you do not plan it, means you do not run it, and suddenly up to here the servers are started, but this server did not start because there's some issue with your Terraform code. So what happens? Your infrastructure is built, but one component is not built. If there's no component properly built, is it worth running this whole infrastructure without the backend database?
No.
Can we run an application without database, guys?
No, it can't be built.
Okay, hope you understood. We cannot run bits and pieces of infrastructure. We need to have full infrastructure. That is exactly why your plan will help you to validate that whether you can think everything is perfect. Okay. Now applies. Then the main like the heart and soul of the whole Terraform is this apply button. So we need to go and apply and provides this file. So normally this file that we talk about in Terraform is extension of TF, Terraform. So the file name will be TF. Okay, so if you go to this this one, see here, this is called apply, and what will happen is you got this example. If you go to this, what about we're talking about destroy.sh. So we have example simple SQL server, main.tf, run.sh. Okay, so what we're trying to do, there is a bin apply.sh somewhere. I think you will have this apply. See here, this file. In this file, what you see here, this is exactly I'm talking about. You have init, you have plan, then you will go and apply. So these are the commands that we are using to run the infrastructure. This is running through an sh file, okay, which is nothing but a shell script. Shell script is helping us. Example, I'm typing here. This is the same commands I can type here. Terraform init, Terraform plan, everything I can do it. But every time manually will I go and type? No. So that should also be happening in a small sh. This is a simple shell script. I read it and I just run the shell script file. That is exactly this guy is doing. He's running this shell script file. That's called a run.sh. Run.sh means it runs that particular sh file. What it runs this sh file. That means that you are applying your Terraform infrastructure. So now we're going back to your basics. The apply button will actually go and work. It actually deploys everything. Or if it is updates, it will updates. So it actually delivers it's $1 million button where it go and apply everything. Okay, and that is the actual button that people will use. Finally, we're talking about Terraform destroy. So Terraform destroy is nothing but it will delete. For example, you might have seen here just now. There is one somewhere we can see the destroy.sh. See here, it's very simple. Destroy.sh means it will go and destroy. So if you go to this infrastructure and try to see where is the destroy.sh, the command will be Terraform destroy. This is exactly what I'm talking about. Okay, so it will help not only to start, but it will help to stop the whole infrastructure. Okay, so now what you have learned, 4 important commands: Terraform init, Terraform plan, Terraform apply, Terraform destroy. So these are the 4 commands you have to learn, which have different purposes. And where you will apply that button, you will do it, apply init, and for the plan, you will show the TF file. Terraform init is okay, but Terraform plan you show. Terraform plan space main.tf. Terraform apply space main.tf. Terraform destroy space main.tf. So it destroys everything. Okay, so that's how the whole infrastructure works, and that's how your 4 commands of Terraform is there. Okay, and if you go into the details of this code, you can see here there is something called variable. This is called variable. There is something called provider. There's a provide section. There's a resource section here. There's a resource section here. So every file will have this common, and we also will have some data source and other components, which I don't want to discuss right now. But within your Terraform code, what are the important components is what this. So this is core concepts of Terraform. When you're writing the code, you will say, I am now creating a variable. I am not creating a provider. I am now creating a, see here, it is Azure. So now here I'm creating a resource. So everything have a specific purpose, which I will discuss next session if you want. But as of now, these are the 4 important lifecycle methods of Terraform. Okay. So init, plan, apply, destroy. These are the 4 lifecycle methods of Terraform. Okay. Understood?
Yes, sir.
Yes.